So these notes we got in the first unit, but if you lost them, I'm giving you a chance to fill them out again. Conditional, hypothesis, conclusion, converse, and counterexample. What's going on? The test is Wednesday, English test, last grade of the 6 weeks. Now, if you did have this hiding somewhere, then you wouldn't have to be doing this right now, but no, you did have it, so you already had it. You didn't have to. This is number 7 on your logic notes. Nope, it's number 6, sorry. It's number 6. The negation of a statement. The word is negation. Number 6, right? Negation. Negation is when you put the word not, is number 6. When you put the word not in front of a sentence, like you probably do with your parents all the time. You take what they say and you negate it. So it's going to have the opposite truth value, which is just fancy for saying if the original is true, the negation is false. If the original statement is false, the negation is true. So this is where you put in the notation, put squiggly P. It means not P. So put that where it says notation in that last column. Squiggly P. In that other column, the column that's empty, yeah, that's the notation. Okay, so the next word, number 7, is inverse. Kind of sounds like converse, but it starts with an I. Inverse. The inverse of a conditional chooses to negate both the hypotenuse, not the hypotenuse, oh my goodness, I'm in a right triangle now, the hypothesis and the conclusion. So, it says not hypothesis, not conclusion. So, the notation is, where it says notation, put not P, not hypothesis, then not conclusion. Not P, then not Q. Squiggly P, arrow, squiggly Q. And this will make more sense when we do it with actual sentences. That's a Q. Yep. Okay. Alright, so the conditional is if P, then Q. The inverse is if not P, then not Q. So, if today is Friday, then tomorrow is Saturday. Flip over to the back of your notes and write the inverse of that sentence. Yeah, tell me, read it for me. Read me the sentence you wrote, the inverse. The inverse of this. What's the inverse? Oh, okay. Trinity, what's the inverse? Yeah, very good. If today is not Friday, then tomorrow is not Saturday. That's the inverse. You put a not in the hypothesis and you put a not in the conclusion. Let's talk about the truth value. If today is Friday, okay, pretend like it's Friday. Is tomorrow Saturday? Can you prove it wrong? No. That's how our calendar is set up. If today is Friday, then tomorrow is always Saturday. That's true. Okay? If it is not Friday, then tomorrow is not Saturday. Is that true? Okay, today's not Friday. What day do you want it to be? Monday. Let's have it be today. Today is Monday. Tomorrow's not Saturday. Is that true? Yeah. Could you prove this wrong? A day that's not Friday, well, you would want it to not be Friday, check, and then you would want it to the next day to be Saturday. Well, that doesn't work. So, The original is true and the inverse is true. Let's practice some more. Keep going on the back of your notes. Write the inverse and determine if it's true or false. I will call on you. Write the inverse. So you write the sentence, but you put the word not in it. We have some room back here to write this, okay? So we added on to this. You might have this somewhere. These are old notes, but this is called negation. This is called an inverse. This is when you do not P or whatever the hypothesis is. It's an inverse is not P, then not Q. So we're taking the hypothesis and the conclusion and putting the word not. All right, Alex, what is the inverse? I'm ready. Read me the sentence, the inverse of that sentence. No, I want you to read me the inverse of the sentence. What do you do to make an inverse? Okay. Okay, you negate it, yeah. So if two angles, what's the opposite of forming a linear pair? Do not form a linear pair, okay? If two angles do not form an LP, then what? Good. Then they are not supplementary, and that's what you should have on the back of your notes. Then it said determine the truth value. We have a 50-50 chance, but we need to get it right every time to get all the points on our test. So, truth value. If two angles do not form a linear pair, what would that look like? If two angles do not form a linear pair. Do you remember what a linear pair looks like from last week? I made you draw one on your whiteboards. Remember, linear has the word line in it, so there's my line. And then how many angles? Pair. How many? Two. That's a linear pair, angle 1 and angle 2. So I want two angles that do not form a linear pair. And it's saying that they're not supplementary. So could I have two angles that are supplementary? They add up to 180, but they don't form a linear pair. Is that allowed to happen? Could you draw a picture of it? I'm going to draw a 30-degree angle. What's the supplement of 30? 150. Thank you, Trinity. I'm going to draw a 150-degree angle. Are those supplementary? We force them to be. Yes. They are, yes, supplementary. Do they form a linear pair? They don't form a straight line. They're not connected. They're not adjacent. So no. So tell me what the truth value is of this sentence. I just proved it wrong. So what's the truth value? First period. It is false. I just found a time when they do not form a linear pair. Check. But I made them supplementary. They were supplementary. So that's called a counterexample. I made the beginning true and I turned it into a liar. That sentence is false because I can draw a picture that proves it wrong. Okay, Jonathan, close that book. Next sentence is on the board. If a triangle is right, then it has exactly two acute angles. Write the inverse of that. What's the new sentence? What's the inverse? Let's go. If.
I'm not reading that one.
Okay, but you just. Okay, I'll read. Okay. If a triangle is not right, if a triangle is not a right triangle, then, what did she say? It has not exactly two angles. It does not have exactly two acute angles. So hopefully you wrote something similar to that, maybe with not abbreviating as much as I did. Okay, what is acute angle? What is an acute angle? What does it mean? Less than 90. Okay, so we want our triangle to not be a right triangle. So it might look like this, or it might look like this. Those are not right triangles. No right angle, no right angle. Okay, so there we go. If it's not a right triangle, we drew some pictures, then it does not have exactly 2 acute angles. How many acute angles does this one have? Can you tell? How many of those are less than 90? All 3 of them. Can you tell how many of these are less than 90? 2. Does that triangle have exactly 2 acute angles? Because the other one's obtuse. Yes, it does. So, we found a time when it doesn't, and we found a time when it does. So do I put true or false? Good, you put false. Because if you can find even one time that it's not true, even one time, the whole statement is false. Okay, here's our last inverse one. And then we'll move on to something else. Last inverse. Write the inverse of this statement. If an angle is not right, then it is acute. What happens in math when you have like a negative -4? What happens? It becomes a positive. That's right. So what happens in English when you have a not? I am not going to the store. Yeah, what? What does that mean? If I'm not going to the store, what does that mean? I'm going. I am going to the store. The negatives cancel each other. If I'm not going, I'm going. So, let's see, Richard, what'd you get for this one? If, yes, wait, good. If an angle is right, you see what happened there? It was a not. So a not turns into a yes and is a true. Okay, keep going, Richard. I'm ready now. Then it is not acute. All right, true or false? An angle, it's not right. It's not. Oh, sorry, it is right. I'm so sorry. An angle is right. We have a right angle. I was doing the original, not the inverse. We have a right angle. True or false? It's not acute. Could a right angle be acute? Never. So we finally got a true one. Yay! True. That one's true. If it's a right angle, it is surely not acute. It can't be acute by the definition of the right angle. All right, let's move on. So, an important part of being a geometry student is to not only be able to solve things, but be able to back up what you've solved. You can do that informally by, you know how on the test when it says explain or justify here in this box, you know how I'm allowed to give you points back if you do that? If you write stuff in that box, I've given lots of people points back before. That's you backing up what you did. You're explaining it. You're justifying it. Then, you know how every time you learn something that says theorem after it, someone has proved that. Someone has written a proof. Some mathematician has written either a flow chart or a paragraph or a 2-column. They have proved that it's true. So it's important in math always, not just to be like, oh yeah, I think this is right, this looks good, but to actually back up what we're doing and prove it. Use reasoning to determine if the statement is true or false. So we're going to decide if these are true or false. Let's name them. I'll call this A. So on your paper, I want you to put A, and I want you to put true or false, where you've been writing all these sentences. I want you to decide. Read it to yourself and decide if it's true or false. We're going to use our logic skills. We did something kind of like this on the warm-up today. You have to really know your vocab to do these. If we don't know our vocab, then this just doesn't really mean anything. If an angle is acute. Okay, let's stop there. That's the hypothesis. So, it's acute. What could it measure? What's the range? What could it measure? Less than 90 and greater than 0. Okay, So we already know that our angle is either greater than 0, less than 90, somewhere in that range. Okay. The measure of its complement is greater than the measure of its supplement. Now, wait a minute. Complement, what does that mean again? Add up to 90. Thank you, Helen. Supplement, what does that mean again? Does the statement have any validity at all? Does this make sense? You need to be able to use common sense in life, right? Let's use our common sense. It really doesn't matter if our angle is acute or not, but it has to be acute for it to have a complement. But anyways, its complement is greater than its supplement. You think that can work? You think that would happen? Absolutely not. Could not happen. So what's the answer to A? False. Write down false. Let's move on. Common sense tells us that is not true. 90 will always be less than 180. When you subtract from it, that it'll always be less as well. This is B. Write B down. We're going to decide if it's true or false. A pair of vertical angles could also form a linear pair. When you're deciding, I want you to draw a picture. Okay, we have a picture of vertical angles up here, and we have a picture of a linear pair. Could the purple ever be the teal? Could these two angles that are opposite of each other ever be next to each other? Could this ever be this? True or false? We have a lot of false statements today, don't we? False. Absolutely false. You can't be opposite and next to at the same time. These are next to, and these are opposite. You can never be both. Sorry, you can't have it all, right? Next one, C. C. If a ray divides an angle into two complementary angles, then the original angle is a right angle. Man, that vocab is coming at you. Draw a picture. Draw a picture and choose true or false, because I'm not going to be there to help you decide if these are true or false. True or false? Yes. Reasoning? Yes. Vocab? Yes. Give an angle day and angle yak are a linear pair. So that's what we know. We know that they are a linear pair. What can we conclude? Where can we go from there if we know two angles are a linear pair? What else do we know about it? They equal what? They add up to equal 180. Look at your list. Where is that on there? Look at number 23. See number 23? Okay. If two angles form a linear pair, then what's the conclusion? The conclusion's on this paper. Then they are supplementary, which is what Helen said as well. But we're not using the word 180. We're just saying that they're supplementary. And then the reason why, the why is you name the theorem. That's when you name the theorem. Linear pair theorem. So it's kind of like, let's just say you just accuse someone of stealing something. You accuse them. Well, you can't just like bring them into jail and be like, they stole something. Well, why did they steal something? I don't know, they just stole something. You would have to back it up, right? You would have to be like, oh, well, we caught them on camera and we have footage. And so you have to have a conclusion, okay, this person stole something, and the why, you have to back it up. And in this class, we're not backing up with camera footage, we're backing it up with theorems or definitions or postulates. Okay, here's what happened. That's what happened. What's the conclusion? Richard, wake up. What's the conclusion? What do you think, Chris? What are those? Yeah! Angle 1 and angle 2 are vertical angles. And now we look at our evidence list. How can we back that up? Not just because I said so. That's not one of the reasons. Did we use a theorem or did we just use like a definition? You know, we know that they're vertical angles, but can we go past that? Look at your sheet. What does the vertical angle theorem say? You see that one? Number 20. What does it say? Thank you. Do y'all know what that symbol means? The little equal sign with the squiggly on top? Okay, so it's given that they're vertical angles, so what's the conclusion? It's always after the comma. What's the conclusion? Then, good. Angle 1 is congruent to angle 2. Can I write A and B like my paper says? No, I have to apply it to this problem. Okay, and why are we allowed to say that they're congruent? Because of the... I start talking louder when y'all look like you're falling asleep. E-O-R-E-M. Good. So the conclusion is that they're congruent. The Y is the theorem from our evidence sheet. Woo! Okay, we're almost done. Given the measure of angle nat plus the measure of angle wed equals 90. What would you immediately conclude? Those are complementary angles. Y'all are getting good at this. Those are complementary angles. And this one's probably not going to be a theorem. This one's a definition. What do I write? What's the Y? Definition. That's not so bad. Of complementary angles. And it's on your sheet. They're all on here. All the ones you would need to use. Okay, so we're going to stop there, and I'm going to let you practice because I